amplifier. First one is desensitization or stabilization of gain. First point you see, stabilized voltage gain. So I told you the voltage gain remains constant for a fair enough long range of frequencies. So we are going to see how. Okay. So we are going to see how this is done using negative feedback amplifier. The very first property we have taken, it is desensitization or stabilization of the gain. See, in amplifier, we use many components like transistor, we use FET, we use resistors, we use biasing resistors, we use power supply, we use capacitors, bypass capacitor, coupling capacitor. So all these devices, they are not going to work in the same way always, because when the temperature is going to change, increase or decrease, their behavior is going to change. Whenever these components become old, they don't function as they are expected, and whenever you are going to replace some of the components, it may not work with the already present existing components in your circuit. So all these reasons will cause the change in gain. The gain value will try to change. It is going to become variable. It's not going to be constant. But if I'm going to have a negative feedback for all these issues, the variability of gain or the fluctuation in gain can be completely eliminated. So the variation in gain is caused by these parameters. Aging, the component becomes, where I'm using the same resistor for 10 years, it becomes old, right? It cannot work the same way as it was 10 years ago. The temperature is rising or decreasing, again the parameter is going to change. If the parameter is going to be replaced, again it is going to change. All these parameters are going to make my gain unstable, or they are going to cause the gain to fluctuate. So the closed loop gain of the amplifier is given by, you know, this formula. See, this AF expression you should not forget in this unit, because we'll be using this only everywhere for negative feedback. So you should not forget the formula for AF. AF is equal to A by 1 plus A beta. So now what I am doing, I am going to differentiate this AF with respect to A. And you see A is present in both the numerator and denominator. So I'll be using U by V method. So if you use U by V method, what is the differentiation of U by V method? Can anybody say? What is the definition of U by V method? The differentiation of U by V method. Fast. What is the differentiation of U by V method? Rishi. If you differentiate U by V, what is the expression? Rishi, you are there? Rajapandi? Nobody is there in the class. Shall I quit the class and go?
So UV dash minus
Yes, sir.
Yes, V dash. What is the
UV
answer?
dash minus VU dash by U squared. Sorry, by V squared.
V U dash minus U V dash. Okay, first U V will come. V U. If I have U by V, V U dash minus U V dash by V square, right? So see here, 1 plus beta A into differentiation of A is 1 minus A into differentiation of 1 plus beta A is A. Okay, so V U dash minus U V dash E square. So 1 plus beta A into 1 minus beta A by 1 plus beta A the whole square. So if you see the numerator, 1 plus beta A minus beta A, plus beta A and minus beta A will get cancelled. Okay, so what you get is 1. So 1 by 1 plus A beta the whole square. So dAF by dA is 1 by 1 plus A beta the whole square, or I can write dAF equal to, cross multiply, dAF equal to dA by 1 plus A beta the whole square. We are doing this to prove that there is stabilization of gain. For that only, mathematically we are trying to prove how the gain is stabilized when I am going to apply negative feedback. So till this point, I think differentiation, everybody is clear. After differentiation, what I do, I just cross multiply. So dAF equal A by 1 plus beta A the whole square. Now what I am doing, see, dividing both sides by AF. So here dAF I have by AF. Here this term into 1 by AF. Okay, I am dividing both sides.